Hello all, welcome back. Today we'll solve one problem related to geometric progression. So this question appeared in CAT 2025. So an is the nth term of decreasing infinite geometric progression, and if a1 plus a2 plus a3 equal to 52 and a1 a2 a2 a3 and a3 a1 summates to 624, then what is the sum of the entire geometric progression? So typically, when can we do the summation of a geometric progression? Right now, only if it is a decreasing geometric progression. Say if it is an increasing geometric progression, the sum will tends to infinity. The only way a geometric progression can be summed is when the progression itself is in a decreasing progression. So what do you mean by decreasing progression here? So typically when the common ratio, that is tn divided by tn minus 1, is less than or equal to 1, then we can say the progression is a decreasing geometric progression. In fact, it should be less than 1, not even equal to 1, because even if the common ratio is 1, it will tends to infinity. So here we clearly know the common ratio r would be less than 1. Now let's begin, what they have given us. So we have three terms. A1, A2 and A3. So typically we write the first term as A, second term AR square, and so on and so forth. But if you see the second equation here, we have A1, A2, A2, A3, and A3, A1. So this means there will be some sort of cyclical multiplication here. So in order to simplify the calculations, let's consider the first term as some k by r. The second term will be where r is the common ratio, and now we multiply r to the first term, that will give us k, and we multiply the common ratio to the second term, that will give the third term, that is kr. So this means essentially k by r plus k plus kr equal to the first equation, which is 52. Now let's substitute these things in the second equation. So substituting will give us k square by r plus k square plus k square r. This is equal to 624. Now if you look at this, we have some common terms, and we can take that off. So this implies we have, let's take the k common here, k into r plus 1 by r plus 1 equal to 52. Here also we have k square common. Let's take the k square out, and this will also give us r plus 1 by r plus 1. This is equal to 624. Let's call this equation 2, and let's call this equation 1. Now let's do 2 divided by 1. That implies, if you see, the common terms will be cancelled, and we are left with only these and these. That means k square divided by k equal to 624 divided by 52. Upon solving, this will give us k equal to 12. Now we can substitute this value in the first equation. So let's do that. Now we have k equal to 12, and now we have r plus 1 by r plus 1 equal to 52. This implies, let's carry out the terms and simplify, and this will give, after solving this quadratic equation, we will have roots as r equal to 3 comma 1 by 3. So but we know, right, this is a decreasing geometric progression. which means R should be only 1 by 3. It can't be 3. So now we know R, and now we also know the K. So which essentially means we know all these terms. So but we don't need all of them terms, because the sum of an infinite geometric progression is given by the formula A by 1 minus R, where R is the common ratio and A is the first term in the series. Now we know R, which is already 1 by 3. Now the first term in the series will be the first term equal to K by R, that is equal to K is 12 divided by 1 by 3 equal to 36. Now let's substitute all that we know. That will give us 36 divided by 1 minus 1 by 3. This will simplify to 54. That will be option 1. Thank you.